Hello guys, my name is Sumit and today we are going to create a movie recommendation system using machine learning in Python. So first of all, I want to tell that we are using Cosine Similarities method or topic from which we will develop a movie recommendation system. So when we create a machine learning project, we want some data. So here we will go to kaggle.com website, and from here I will download one movie dataset. So let's see. So this is TMDB movie dataset. So I will download this, which is a 9 MB. You can download it from kaggle.com datasets TMDB movie datasets. So after installation, we have to extract this file. So there are two files here. First of all, we will create one folder here at the desktop to start. So we will name it as movie recommendation. Okay, welcome. And here we will just drag and drop these two files. Close this and we will right click here and open with code. You can use your code editor. I am going to use a VS Code. Now before starting the video, let me tell you what we are going to use in this project. First of all, we are going to use Streamlit. So what is Streamlit? Streamlit in Python helps to visualize a model in the form of website. I will show you later on. We are going to use JobLib. JobLib is used to the main purpose of the JobLib. It stores the trained data or trained data set or trained model at the folder, so that we don't need to train again and again. So training of the data can be more time complex, can increase more time complexity of the website, and sometimes the training data can be more and it will require more time to train the data. So once the data is trained, you don't need to have to train again and again. You can save the model and load the model by running the app next time. So this is going to use NumPy to help is to save the data in the multi-dimensional array. We are going to use AST, abstract syntax tree. I will talk this about later. We are going to use sklearn, sklearn website, which is a very important library in Python for machine learning. We are going to use count vectorizer. What is count vectorizer? Which converts the text into vectors so that we can perform analysis or machine learning process. And next we are going to use NLTK, which is Natural Language Toolkit. It's a powerful library in Python for work with human language. Okay. So these are the libraries we are going to use as for now. If there will be anything more, I will just tell you. Okay, so we are going to open a VS Code. Let me rename this file as a small name. Here, let's give this as credits CSV and give this as movie CSV. And now we are going to make a Python. We are going to make two files. First is training.py and movies recommendation.py. So here we will train the data and here it will show the data, or we can execute the output. So first of all, we are going to write the training data. So first of all, we are going to install the important libraries, which is pip install pandas. So it will install pandas. Then we have to pip install Streamlit. I have already installed in my computer. I'm just showing you. Pip install NumPy. Okay. I'm just zooming it so that you can see. Pip install AST, which is abstract syntax tree. Okay. Pip install sklearn. Pip install NLTK, and that's all. If there is any more libraries, you can install this if there will be an error for you, because I have already installed everything. So I will import JobLib. which is used to save the data and the model. We are going to import. Please write comment what I am telling. For example, I am telling that joblib used to save the train data and load the model, so you can comment out and write this here. Okay, so import Streamlit as st, import numpy as, let me give this as st, numpy as np, import pandas as pd. Okay, so wait a minute, what I am going to do, I will just I'm not going to use Python extension here. I am going to use ipynb, which is Jupyter notebook, and here also I will going to use ipynb, so that we can execute the particular code. So here I will paste this code. So what it will do is importing required libraries. If this Jupyter notebook is not working in your computer, so that you can download extension for Jupyter notebook. You have just to use ipynb as an extension, so it will execute Python in a like as a Jupyter notebook. It is the advanced version here as the VS Code. So pandas is so we have to also from sklearn dot future extraction where dot text, we have to import count factorizer. You don't have to memorize all this, it's just the libraries, sklearn dot feature stream dot text and import count factorizer. And next is we have to import NLTK, which is used to work with human language data, and from NLTK we have NLTK.stem.porter. We have to import porter stemmer. That's all. And the last thing, we have to import Cosine Similarity, the method we are going to use here, which is Cosine Similarity for machine learning. So I will explain to you what is the Cosine Similarity. First, let me import it. So that's all the libraries we want for today's. Okay, so main topic here is cosine similarities. Let's check out. If we don't talk about the mathematical operation, what a cosine similarity do is it compares the and show the similarity between two sentences, just like that. It can value lies between 0 and 1, that measures similarity between two vectors. A value closer to 0 means the vector are perpendicular, while closer to 1 means the vector are similar. If it is closer to 1, then that is the chances that the vectors are similar. So formula for similarity is A dot B, and this we don't need to see formula for now. We have to just understand what the topic is, what the main topic is. So for example, there are two sentences, hello world and hello. So we have to just create a table like this. Let me show you. There is an Excel row. Yeah. For suppose this is hello and this is world, and this is sentence 1 and this is sentence 2, and there is an in sentence 1 there is an hello world, and in sentence 2 there is an hello. Okay, so we are going to plot these two sentences here. So first sentence is hello and world, so we will write this here 1 and here also 1, and second sentence has only hello, so we are going to write hello, and here we are going to write 0. So we are going to plot this in the graph. So let's draw a graph. So this is a graph, and this will be sentence 1, which is on x-axis, and this will be sentence 2, which is y-axis. Now we have to plot. So first we are going to plot hello. We are going to plot hello in both the sentences. So it is one from x-axis and one from y-axis. Let's plot this. suppose this is hello and this is hello, x-axis and y-axis. Okay, and the second is world, which is on the x-axis but not on the y-axis, so it will be here like this, and we have to just draw this line here and we have to connect. So here we can see this is a cosine angle and this is a 45 degrees. So cosine 40 degrees is something about 0.71, I think so. I think so 0.52. So 0.52 chances, 5 to 52% chances that these two sentences are similar. Just this is a very simple example for that, so we don't need to understand in deeper. We just going to use the concept in this code. So now we have imported the required libraries here. Now we are going to import a dataset. So importing datasets. Here we are going to first create a credits df. Df means data frame, so you can take any variable you want. So read csv, we are going to use a csv file, that's why we are going to read csv. This is a pandas inbuilt functions, so we are going to import the credits.csv. and the second library dataset we want to use movies data frame pd.read csv movies.csv. That's all. We have imported a dataset. Let's check if there is any issue here in the first code. So if it is running properly, then there will be no issue. Yeah, there is one issue. Cannot import Cosine Similarities from analytk.stan.porter. Let me check here. Sorry, here we are going to use matrix, and here we are going to use pairwise. Let me run this again. Analytic matrix pairwise. Here we are going to use sklearn. So this is an sklearn. Sorry, it is not from Analytic. Yeah, it's running properly. Everything is fine. Yeah, it is reading the data properly. We can see the data like this: movies df.head. So it will show the first 5 data of movie. Yeah, that's showing. And if you write tail, then it will show the last 5 data of the data sets. So now this if we use movies df only this much, so what it will show is first 5 data and the last 5 data. Okay, but now if you want to see the whole data in this output, so you can use pd.set option, display dot max column. Don't need to worry about syntax, it is as it is. Inbuilt function. So we have pd.set and display dot max rows. So what it will do is it will display the max row and column. It will display the whole data. So this is the code for that. We don't need it for now, so we'll comment it out. Now the second is we have to combine credit and movies. We are going to combine these both data sets into one, so that it will be easy to work on one data set. So we are going to use movie data frame is equal to movies data frame dot merge, and here we will write a credits data frame, and on we are going to use title. So what this code will do, it will merge the credits data frame and the movies data frame into the movies data frame. And on title means this will not merge the title column, because there are 2 title columns. In credits we also have title columns, and in movies we also have title columns, and we don't need multiple title columns because they both are same. So this will not copy the title column, but it will copy the credits data frame in the movies data frame. That's all. So the next step is we are going to keep only the important data sets in the movie DF. So first we want movie ID. These are the important things we want in the column, and rest we are going to skip. We want title, we want overview, we want genre, we want keywords, cast and crew. This is all the things we want. Let me run and show you. Movies df dot add movie ID. Let me check what's the issue here. Movie ID, genre, cast, crew not in index. Let me check. ID is there, keywords is there. Okay. So here we are going to use ID. Sorry. Here we are going to use. There's a title here. Or instead of title, we are going to use original title. Original title. And next is overview is there. Original language. Overview genre, we don't have genre here. Let me check in credits. There is a cast, crew. Okay, cast and crew is there. Okay, one second, let me check whether movies DF is working or not. What are the data? There is a budget, genres, homepage, keywords, original title, popularity, production companies, runtime, vote average, vote count. Movies DF that much, credits DF. Credits DF. Let me check what is credits DF. Credits.csv. Credits df.add. So there's a title, cast, crew. Cast crew is there already. So we are merging movies DF. Let me check if this is working. Yeah, this is working, and now we have merged the cast crew. So we have to run this all. Let me run this all so that it will perform every operations here. Everything is fine. Now we are going to create a code, and here we are going to merge movies DF with movies DF dot. We are going to use array inside array, and we have to mention the columns we are going to want. Okay, so we want movie title, ID, original title. Let me see, or there are genres. Yeah, genres. Okay, genres. We want keywords. Okay, we want keywords. We want overview. Yeah, there is an overview. We want cast, and we want crew. Everything is fine. There's an ID, there is an original title, genres, keywords, overview, cast and crew. Let me run this. Yeah, everything is fine. Let me show this data. So there is an ID, original title, genres, keywords, overview, cast, crew, which is combined in the movies DF. So this is the last data for movies DF with the things we want to perform machine learning, or we can say Cosine Similarity. Now the next thing we have to drop. Now we have to clean the data. This is our data is organized, manipulated, everything is okay. So first we have imported libraries, we have imported data sets, then we have merged the data set, both the data sets, then we have only those columns that we want to perform machine learning. That's all we have done till now, and now we have to clean the data so that we can train the data. Okay, so the next step is we have to drop missing places. Okay, for example, if there is any not available portion in this code, so we will just drop that. So for that, so movies df dot drop na, so it will drop na in every, if there is any data set where the data is not available, it will drop that data. So input is equal to true. Sorry, we don't want to write a semicolon, so in place is equal to true, so it will drop the any data. Let's check if there is any null point here, is null dot sum. So what it will do, it will check if there is any column where there is a null value, so it will sum that and will tell us. So there is no null value in the total data. Okay, now the next step is 2. Now the concept called AST we are going to use here. The library which has imported abstract syntax tree, so we are going to use here. So first of all, there is a keyword. Okay, we can see keyword, and in keyword there is, we don't want this ID, that's all. We want only this name. Okay, name is culture class, that's all. So we want only these things. Okay, so what we are going to use, we are going to create an array, and we are going to store this name data inside the array, that's all. And we are going to append this in the database. So let's do it. So for that, we are going to create a function where we will pass an object. We will create a L which will be empty, and for I in st dot literal eval and object. So it will just what it will do is it will remove this ID, and we are going to use, if we check if there is a name, so we will only consider the name, we will not want ID, and that's all. I am going to write the code and show you. So what we are going to do, we are going to L dot append, and in append we are going to I name. So only the name data will be appended in the L, and after that the L will be stored in here. Okay, so we will return L. So to everything is okay, function will be work fine, and but now we have to apply this function into this column, keywords column. So let's apply this. Okay, so we are going to use the general column also. Here is also name, so we don't want ID, and we are going to apply in both genres and keywords. So we will write a movies df of genres is equal to movies df genres, and we have to dot apply, and we are going to use the function convert, and the same for keywords. Let's check out. We will print the movies df dot head. Convert is not defined. Let me check. Okay, we have not run this. For you to run this first, and now we have to run this. AST is not defined. Let me check. Import AST. We forgot to import AST. Import AST, and I will run this, and after this we will run this. So we can see here in genres and keyword, ID is gone, and the name data is shown here in the form of array. Okay, the next thing is cast and crew. We have to remove cast. First we will what we will do is we will want only character in cast, so we will make a object. So we want to take only 3 characters, not more than 3. If there are more than 3, we are going to just stop. So we will create an object for that, def convert 3, and place inside object, and L is equal to empty. we are going to use counter for this to check whether it is more than 3 or less than 3. The counter is equal to 0 for I in ast dot literal eval and object. And if counter is not equal to 3, then we are going to append I and name. Okay, and counter plus equal to one, else break. If there is if the counter is more than equal to 3, then we are going to break and we are going to return L. It's fine. Okay, let's see. We run this and yeah, okay. Now we will put movies df cast is equal to movies df cast dot apply and convert. See, fine. Now let's run this. There is any problem? No. Let me check. Main form node dot string. We are going to use cast dot apply converter. Use this. This is an error. Main form node or string, same word, Zoe Saldana, Sigarna, Siver. Just a second, let me just debug it. Let me check what the error is in ChatGPT. Let me give him the code here so that he can debug it. Using ChatGPT is not a crime until you are getting the right data or the right thing. Just copy this. Let me check if it's working, then we will see how it's working. Yeah, it's working fine, but the cast is empty. Let me write your name. Oh, it can be empty. So there's a cast def counter L is equal to try. Let me try again. So let's remove the cast. We will check it later. We don't need cast for now. we are going to ignore the cast. So what we will do is we will movies df is equal to movies df dot drop column cast. Let me check if the cast is removed or not. Okay, it's removed. We don't want cast for now, and we will also remove the crew. We will perform only on these data sets. Okay. Now what is the error? Okay, so cast is removed, that's why. Okay, let's run this all again. It will suffer everything. Okay, so cast, so we have keywords, overview and genres. We are going to predict with all these three data. Now the next step, we are going to split the overview. Where is overview? Yeah, it's a sentence, and we are going to split it by the comma. Okay, we are going to replace this space by the comma. We are going to first remove the space in the genres. Here there are spaces. For example, here between science and fiction there is a space. As you can see here, it will just remove the white spaces. So this is called the cleaning of the data. Let's do that. First of all, we are going to split the data of overview, movies df overview. I will show you what it will done. What it will do is equal to movies over df overview is equal dot apply. As we know, this is a lambda function. Lambda is a Python function, inline function. We are going to I dot replace, sorry, first we are going to split the data, x dot split and movies df dot head. Sorry, there is a spelling mistake here, apply, and now we can see the data is splitted into a with the colon comma, and it is considered inside, and this is called splitting. Now the next step is to remove white spaces. So movies df of genres, this is called the cleaning the data. First we have to organize the data, then we have to clean the data, then we have to train the data, then we have to test the data, and then we can use the model, machine learning model. Yeah, that's the step for machine learning. And now movies df genres dot apply lambda x I dot replace, and here we are going to replace this with this. We are just removing white spaces, so it will do for I in x. Sorry, there is a spelling mistake. This is genus, and now okay. Now the next is in cast. Also we are going to remove this. Let's do same for first keywords. We don't have any cast, so sorry. Yeah, fine. We don't have to do for casting tree because we have removed that, and now we are going to put a column text. Now we are going to make a column called tags, and we are going to put we are going to combine genres, keywords and overview into a simple small tags, and we are going to add those all the tags in a tag field in the df. So I think so understood. So let's check. We are going to create a new data frame, and in this new data frame we are going to add movies df of movie id, original title, I think so it will be multi-dimensional array. Yeah, original title, genus, sorry, we want only text. Here in the text we are going to combine the genus and overview and keywords, and this will be id and original title. So we will get new df of text, and here we are going to combine all this. Okay, movies df of overview plus movies df of genus plus movies df dot keywords. Let's me run this. Text not included. Everything fine. Tags not in the index. Oh sorry, I think so I have done some mistake here. Tags, here is tags. Not in the index. Why? Let me run new df dot head. Sorry. Here we are going to create a movies df of text. Sorry, here only we are going to create a text, and here we are going to add all this. So I will copy this here. I will paste this, and instead of new df I am going to use movies df text is equal to movies df over it plus movies df, and here we are going to see the head. So here we can see there's an original title, there is a text. Also get this, in this tag the genre, overview and keywords are combined. Okay, so now we have to just remove this. Let's see what we are going to do next. So in this tag we are going to making all the letter case lower, and we are going to remove this array and everything. So new df, the cleaning the data is a very big process and very complicated. So it will, if you are using Python for machine learning, it will create more error than just like I have created. So you have to solve that error either with ChatGPT or by your own. It's depending how it's comfortable. Lambda x is equal to dot joins x if is instance of x list else x. Okay, now there is a syntax error. Let me check. X list joins x. Okay, sorry, they will be joined. And now we are going to lowercase the letter, so making all letter. Let me check what is the changes we made here. We have removed the this, what we call this, we have removed commas and we will remove the bracket, so that it is served as a simple single word. Every word is served as a single word here, or we can say a sentence. So now we are going to use making all the cases lower, so we can perform operations. New df text is equal to new df text dot apply lambda x str of x dot lower if pd dot not null x else x. Okay, we are going to ignore this warning. Now let's check. Now we have the cleaning of the data has been over. Everything is fine. Let's check our final data. Yeah, we can see that every case is now lowercase and every data is now clean, and we have combined all the data, all the tags, so that we can find the movies. Yeah, suppose here how it's gonna work, that if we search the avatar, then what it will do is it will took all the tags of the avatar and compare it with other sentences. If the text matches, if the cosine similarity has the highest, then it will show that movie. Okay, this is how it's gonna work. So first, before doing this, we are going to transform these into vectors. So to transform these into vectors, we are going to first if there is an NA, as NA means there is an empty subset, empty place, then we have to remove that first of all, so it will not create any issue. Okay, now we are going to count vectorizer. This is a variable and we are going to use count vectorizer, and max futures 5000. So this sentence, which is max futures 5000, will only take 5000 important words, okay, which are the most important here. It will only take that 5000 words. And the next parameter that we are going to pass here is stop words is equal to English. So what this will do, it will stop the in, the, is, just like these words, preventing them from coming into sentence, okay, or we can say two vectors. Now we have to feed that. Now we have to convert vectors into array. So to convert vectors into array, we are going to cv dot feed transform new df text to array. So now there is the next thing, which is ps porter stammer. So let's check what does it do. The Porter stemming algorithm or Porter stemmer is used to remove the suffixes from an English word and obtain its stem, which becomes very useful. So it was very complicated. Let's check. Computer that removes common successors. It removes common words or common suffixes. Let's do this. So here we are going to use ps is equal to Porter stemmer. Fine. Now To remove the common suffixes, we are going to create a function def stem, and we are going to pass here text, and there will be y which will be empty, and for I in text dot split y dot append ps dot stem of I. This is the function. We don't want to memorize, but what does it do is it removes common suffixes as we run. So return dot join y. Now the next step, we have to just apply the stem. So new df of text is equal to new df of text dot apply and stem. So it's applying, it will take some time, and now I think so our data is ready. Now we have to store data in the saved data in the model. We are going to use, for that we are going to use joblib dot dump and new df. So for why we are storing new df, we want the data in next file, so that we are storing that new df data, and joblib dot dump cv, and we are storing the counter vectorizer which we want in other data. We are going to create one more movie recognition IPYNB where we want this trained model. Okay, so that we don't want to run this again and again. This is what the joblib do. Once the model is trained, we can use it anywhere without training again and again. So next is similarity. So one thing we forgot to do is here we didn't create a similarity, so we are going to cosine similarity, which I have told you what cosine similarity does at the starting of the video. So similarity, we have to store cosine similarity and in vectors. So it will perform the cosine similarity on the particular vectors which we have clean and we have. Okay, so it will store similarity in cosine similarity dot pkl. Okay. So let's check if we'll run this all and we check if we get a model here or not. It will take a time to convert this because it is training the model and the model is too big and data set is too big. It will take time. That's why we are storing the saved model into a. So what is problem? Model object is not callable. Let me check. Oh sorry, here we don't, and now we are going to. Now we can see there is a cosine similarity which we can't open because this is count vectorizer. This is a trained model and we are going to use in our next folder, and movie recognition.ipynb. So our data is trained, we have got our data, we have got our CSV file, and now we are going to store the data in movie recommendation. So let's start this last step. So here also we are going to import joblib and we are going to import streamlit as st. Okay, now we will create a cv variable and we will store joblib dot load count vectorizer dot pkl and similarity is equal to joblib dot load. Okay, I'm going to use cosine similarity dot pkl. Fine. Now new df is equal to job lib.load new df.csv. Second, I'll put this in semicolon. No such files or directory. Let me check if there is an error in spelling. Vectorize counter. Oh, sorry, I have created a counter vectorizer. Yeah, fine. The data is loaded here, and now we have to create a function to recommend movie. So here we will create a def recommend movie. So movie will take as an input, and we will recommend it. So movie index is equal to new df of title. So it will take a title as an input, and is equal to movie. If it's a movie, then dot index. So it will take a title and it will suggest a movie's name. It will input title, and the first matching title will be considered as the movie index. Yeah, dot index 0. Now we are going to use distances is equal to similarity of movie index. So it will search the it will cause cosine similarity to search that movie index, or it will perform cosine similarity to the movie index. Okay, so now movie, we will create a variable movies list is equal to sorted list enumerate. I will tell you what it will do. Distances. Let me show you what enumerate function do. Okay, suppose this is a 1 2 3 4 5, and for values enumerate, print index and value. It print index and value. Okay, just do loop in a sequence in the distances. Okay, now here after two brackets we go to comma and reverse is equal to true. Why true? Why we are reversing? Because cosine similarities at the bottom it will have 1 and the top it will have 0. So we want one which is more cosine similarity, and we'll show at the top, and key is equal to lambda x. So sorry, lambda x is equal to x of 1, and here we want only first 10 suggestions as output. So now recommended movies is equal to new df dot iloc of I of 0. The title for I in movies list. So recommended movies will be at the location or in the movies list. Okay, now we have to return recommended movies. Yeah, everything is fine, no error. Now in the streamlit, we are using streamlit, so we are going to take input in the streamlit. User input is equal to st.text input. Yeah, and here we will enter a movie title, and default value we will give as avatar. For example, choosing avatar, you can choose any movie here. So if st.button. We are going to create a button in the Streamlit as a get recommendation. If it is pressed, then we will call the function recommendation is equal to recommended user input. Okay, now we want to write st.write recommended movies. Now for movies in recommendation, we are going to st.write movie. Streamlit is not defined. So we are going to here use as st. Now let's run the Streamlit. So we can to Streamlit run movies rec.ipynb. Okay, what's the problem is here? It don't perform operation on ipynb. So I will run this here only. Okay, let's run this. Run this all. Okay, for now we are not going to use Streamlit because Streamlit uses only Python. Okay, only py files. So here we are going to, what we will do is we will create movie.py, and now we are going to paste this here. Maybe in future the Streamlit will give option for ipynb files also. Now let's check whether it works or not. Streamlit run movies.py. Sorry, spelling is wrong. Here it will come movie. Now this is a website. It's loading. Yeah, let's check whether it's working or not. So there's an error. Let me check. This is the input. Title. Sorry, we are going to use here original title. Such, and there is I think so more titles here. Yeah, sorry, original title. File C, recommendation input. Authorization. Movie list is not defined. Let's check again. Yeah, now we can see that we have got a recommendation for Avatar. If we write Iron Man, we can get a recommendation for Iron Man. Okay, so it's fast because we have already trained model. If we are going to train again and again, that will take much more times, like 20 seconds, 30 seconds. That's all. It depends on the length of data, size of data. So here I am going to write one more movie. Let's check Titanic. So there's the Titanic, Ghost Ship. So this is where we are going to, so it's working fine. We are getting the movies related to this movie title. So this is how this is working. Okay, we are not using any library for recommendation. We are just training the model, and that's cool. So here in training, we are training the objects. Let me conclude the code. These are the libraries we are importing. We are using joblib for saving the trained model and loading the trained model into the, we are using Streamlit for this visualization, which we have seen on the website. We are using NumPy for vectorization and multi-dimensional array. We are using pandas for cleaning data and data manipulation. We are using sklearn for converting vectors, converting text into vectors. We are using NLTK for human data. We are using STK, abstract syntax tree. We are using photostemmer, and we are using matrix cosine similarity. This is the important, which is cosine similarity. In this, with the help of this method, we are doing machine learning. Okay, for now we are reading the CSV files, both the CSV files. Now we have combined the CSV file, and here we started cleaning the data. We have removed NA. We have removed everything which is ID, which we don't know, which we want only name. We have removed cast and crew. Okay, we have removed spaces. We have combined the overview, genres and keywords in a one called tags, and this is the output we got. And after that we removed these commas and the brackets, and this is what the output we got. And after that we have converted all the uppercase letter into lowercase letter, and then we have converted in vectors. So converted in vectors. Then after that we have used cosine similarities. This is the main method we have used for training the data, and we have saved the data in this format: counter vectorizer, cosine similarity, and UDF. And in the next we have imported Streamlit for visualization. We have loaded data about all the three data. We recommend the movies. If the search movie is in original title, then we are going to search this. Then we are going to find a similarity in the particular movie index that we have searched for. And if it will search all the movies which are similar, and we are going to print top 10 movies, okay, which have the most cosine similarities. That is what this recommend function will do. After that we are going to take user input, and now we will get the 10 top recommendation movies. So this is how it's gonna work. So for more machine learning videos and more projects, stay tuned with us, and for subscribe at 10 minutes go. So thank you. We will improve the videos in the future. So thank you.